This Equipment World video is brought to you by Chevron 600 ADF Ultra Low Ash Diesel Engine Oil. It's time to kick some ash.
Hi everybody, welcome back to Equipment World. You're watching The Dirt. I'm your host Brian, and today we're back to talk about oil again. But we're coming at it from a totally different angle than we traditionally do. We've traditionally talked about how to choose a lubricant and do you need different lubricants for different seasons and things along those lines. But today we're actually here to talk about how do you develop a new lubricant and why do companies bother creating new blends of oil? I'm not a petroleum engineer, but I thought this was actually a pretty interesting subject. So joining us today is Kevin Carabell from Chevron, and he's going to kind of walk us through that process of what it takes and why we even bother.
But before we get into that, I want to take a second to tell you about the sponsor of this video, Chevron Lubricants. Protecting your diesel engine and its exhaust aftertreatment system has traditionally been seen as an either-or proposition when it comes to choosing the engine oil that's going to protect your system. And that's exactly why Chevron spent more than a decade of R&D work developing a no-compromise formulation. Now, I don't have to tell you why a clogged DPF is bad news, but here's the real kick in the pants. 90% of that ash clogging up your DPF and then upping your fuel and maintenance costs, it comes from your engine oil. You might be thinking, why don't they make an engine oil with less ash in it then? You'll be happy to learn that Chevron agrees with you. They've developed a new ultra-low ash diesel engine oil that is specifically designed to combat DPF ash clogging. Delo 600 ADF with OmniMax technology cuts sulfate ash by 60%, radically reducing the rate of DPF clogging and extending the DPF service life by 2.5 times. Before you had to choose between protecting your engine or your aftertreatment system. Now you don't. Delo 600 ADF with OmniMax technology. It's time to kick some ash.
Well, Kevin, thank you for taking time to be on the show today. I appreciate it.
Thank you. Yeah, thanks for letting me come talk. Appreciate it too.
Absolutely. So today's subject is totally different than what we normally talk about, and I'm pretty interested. So my first question for you is, what are some of the overall goals that go into developing a new oil blend? Why bother continuing to modify?
Customer targets change. You're looking at ongoing changes to emission regulations or durability of the aftertreatment system. Customers may want to, and when I'm speaking of customers, I'm speaking from the perspective of the marketers and the end users, but also the oil companies themselves. The oil companies, and not just Chevron, but other oil companies, use a variety of base oils, and they may want to change just due to supply situation or performance improvements. They may want to change the base oil slate that they use with a particular product. They may want to add some OEM claims. They may want to make the product available in different regions. So you may change where you're selling a product. So there can be a number of reasons why things change. You know, it also could be a desire for improved performance data. You know, maybe they want to have extended oil drains, and so they might want to put in some performance boosters for things like that. Markets change too. So, you know, it's constantly evolving.
So at a very high level, what is kind of the process for creating a new oil blend? I'm sure there's someone in a back room mixing things up in a cauldron somewhere. What does that actual process look like?
Start with the customer. The customer will determine what the product needs to look like, what we call the product profile. When I say a profile, that will be the claims that are on the bottle. There's API claims and then there's OEM claims. And those claims have performance requirements associated with them. And each of those performance requirements has a suite of testing that's required to be done to prove that the product meets that level of performance. So there's required tests that must be run. Claims like API have a suite of engine and bench test requirements. OEM claims may use the same engine tests that API does, but they may want better than category performance, and they may have their own proprietary bench testing requirements. So for step one, you got to define the claims. What does the product profile need to look like? And then you want to think about what base oils are you going to use to blend the finished product. And of course, you have to consider target finished oil cost, and then timing can be very important. timing of when the product is rolled out. So that would be step one. Step two, you're going to develop your testing plan. You're going to lay out your landscape of the tests that you need to run. You may decide to incorporate new additive components, new detergents or new dispersants. There may be new performance tests that need to be evaluated. You're going to lay out, in particular, you're going to focus on what are called the formulation setting tests. These are the tests that are for a particular category, the ones that are the most severe. It might be an oxidation test, it might be a deposit test, it might be a wear test, it may be all three. But those are the ones that you're going to focus on because those define the formulation space. I think in terms of systems within the oil formulation itself, there's a wear control system. There's a deposit control system. There's an oxidation control system. So, you get the idea, right? Each system may be needed to be evaluated in a matrix approach for the different formulation setting tests. Or maybe you can use a system from prior technology and just update it a little bit. It depends on the situation. So you lay out your testing matrices, and some of those tests can take a month to run. That means you get, one answer a month. So you got to think about the timeline because you don't have forever to get these products developed either. You run through some of your initial scoping work, and then you analyze the results. And what are you going to do with those? You're going to build models. So you start building mathematical models on the different test parameters, how they respond as you adjust the formulation. And then you start to create prototype formulations for what your product is going to look like. These are initial guesses at what you think the final product is going to look like. We call them prototypes. You do this because you need to start field testing the prototypes. So you got to start putting your prototypes out there in the field to get no harm testing done in parallel as you're continuing to develop the final oil formulation, because it takes several years to get the field testing done. A truck may only get 1 or 2 oil drains a year, so you need to have that out there early, and then you'll revise that as you progress. So you'll do all this, and you'll eventually kind of hone in on refining the prototypes and fine-tuning the performance. And you got to check your finished oil cost. Did you go over the proposed cost targets for that? And you got to go back to your customer and revise the targets because this whole process may take 1 or 2 years. And, hey, things change, right? 2 years later, your customer may want a different product or a slightly different focus on it. So you get that all done and you put together what you're going to call your starting formulation for product qualification. Product qualification is the process where you pretty much fix that final formulation, but then you have to run all the testing to prove the performance. This is the proof of performance part, and that's handled by a different group than product development. We call them PQ for product qualification. So you put together your starting formulation, but you also have to map out contingency space around that because PQ may run into some issues on a particular test that was unanticipated. So you have to have backups. Where am I going to go if this formulation struggles with a particular test or doesn't give a good enough result?
So you did touch in it in your last answer, but why separate out bench testing? Why make that a separate set of tests as opposed to just doing, pretty much all of your engine tests?
Let's, for the sake of argument, group bench tests into three categories. There's one that I would call development bench tests, and these are tests that the additive supplier will create in-house testing to evaluate new chemistry. So they may be looking at coming up with a new detergent, right? Well, does this detergent work? Okay. The chemists can come up with a lot of options pretty fast. They may come up with, 6 or 8 or 10 different options, right? So how do you evaluate those? You can't run 10 $200,000 engine tests. There's just no way. You don't have the time and you can't spend the money on that. So you develop these bench tests that you hope can screen these components in some reasonable way. And everybody's got their own in-house tests. These are not available outside of outside of development groups in general. they may come up with tribological wear tests. You may have a motorized test rig, which you may take the head off of an engine, set up a circulation system to run the oil through, and then have a motor there to drive all that, and that will give you a representation of what the oil will perform like in a real engine. Second would be the API category bench tests, and these assess a very specific aspect of oil performance, and there's a long history to some of these tests. Seal testing is done. There are 5 types of seals that are evaluated in API work. You assess volume change, hardness change, tensile strength change, elongation. You basically soak the elastomer in the oil for a couple of weeks, and then you test it at the end. Does the oil damage the rubber? There's corrosion testing that's done, lead and copper corrosion, in a test called the high temperature corrosion bench test, HTCBT. Foam testing is done. Shear stability of the formulation is done to assess the performance of the viscosity modifier, and it also relates to fuel economy of the oil. There's volatility testing. People may be familiar with the NOAC kind of test. That the drive lately has been towards lower volatility oils because those directly relate to lower oil consumption, and that's important. And also relates to fuel economy. There's used oil, they call it the MRV, mini rotor viscometer test, that you take a sample out of a MAC-T11, which is a heavy loaded soot test, and you measure the low temperature performance, because sooted oil may perform differently at low temperature than fresh oil. And of course, there's also the chemical box, which would be relating to sulfated ash and sulfur and phosphorus levels that are in the oil. So that's the second group of bench tests. Third group of bench tests are what I would call the OEM performance bench tests. And these are the tests that an OEM, an engine builder may develop in-house to protect their hardware. They may have their own tests. And these are often things like glassware tests that are attempting to simulate turbocharger deposits, or they may have their own proprietary seal tests or glassware oxidation tests that may be run with biodiesel. So different tests are out there depending on the OEM.
What are some of the shortcomings? And you and I discussed a few of these in our pre-call, but at a high level, what are some of the shortcomings of bench testing compared to doing actual engine tests?
For simple physical situations where the physics is simple and you have a direct wear mechanism and limited chemical reactions going on, right? Bench testing can work. If the situation is dominated by sort of one physical driver, then a bench test can simulate that. But that isn't generally true in an engine. The oil environments are very complex. You have combustion byproducts that get introduced into the oil. You have water in the oil. You have very high temperatures, high shear situations. The oil is essentially a circulating fluid. There are wear metals in there, and the wear metals will catalyze other chemical reactions. They will behave like catalysts. You have nitrous compounds that are in there. You have partially burned fuel byproducts that get in there. So the oil sees all of this, and bench tests just generally don't simulate that very well. It's really hard to do that on a bench test. And then the other aspect about bench tests is some bench tests respond very well to certain additives, and I'm looking at oxidation tests, right? Some bench tests can respond very well to certain oxidation inhibitors, but the real engine doesn't look at it the same way. So you have to be careful when you're working with bench tests.
How long does it take from kind of the conception of the idea for a new oil blend to the point that we see it as a consumer on the shelves? Roughly how long does it take to develop a new blend?
It takes literally years. What drives that is And it depends on the situation, right? So if it's just a base oil interchange, if an oil company customer has access to additional base oils and they say they want to start using, re-refined, more green oils, that's what we would call a base oil interchange. And those can be fairly straightforward. That can be just a matter of a couple of months. Or they want to introduce a product in a new region and the base oil that's available in that region is different than what the product was initially mapped out to. And that can just be a couple of months. And it may be that they just want to upgrade something. They want to add oxidation performance. So that's a booster. That can be just a few months. But if it's something like new category development and the category is significantly different than the prior category, and I'm thinking in terms of PC12, upcoming PC12 could be a very different set of requirements than the current API CK4 category. And that's partly because some of the engine tests that are in CK4 today were carried forward from CJ4. So they've gone through two categories now, and those tests were developed back in 2004. It's hard to get parts for those anymore. And are they really relevant to the engines that are on the road today? So there's going to be a lot of work that's going to happen for PC12 to come up with some new engine tests. So the tests are going to have to be developed in parallel with the new chemistry that maybe has to be developed. And there's also been kind of a shift towards synthetic and synthetic blend base oils. So the landscape's changing. It takes a couple of years to develop an engine test. If it goes well, it's usually a 2 to 3 year project. It takes up to 5 years to develop new chemistry, a new additive. So, that kind of work has to have started already for PC12. In fact, it has to have started a few years ago for PC12 in order to get it ready in time for a 2026 launch. Things have to be far enough along that the formulation work has to have a couple of years as well, 2 to 3 years to develop that. And that's always the crunch because the engine builders are looking at changes in the emissions landscape, and that's set by government agencies, and they don't budge. There's a date. You got to meet that, right? So that's hard, and sometimes it can be quite a bit of a panic to get it all ready in time, get all the pieces put together.
Interesting. It is funny. As a consumer, we just take it for granted. Here's a jug of oil on the shelf, and no one really thinks about the long process that it took to actually get that product to the shelf. So this has been really interesting. Thank you, Kevin.
Glad to be able to help.
Well, thank you again to Kevin for being on the show and kind of guiding us through this whole process of what it takes to create these new oil blends. Like I said at the beginning of this, I am not a petroleum engineer. I have no interest in becoming a petroleum engineer. But this was pretty dang interesting, and I had no idea this whole process existed. So thanks for joining us. I hope it's been helpful, and we'll catch you guys on the next episode of The Dirt.